Quadratic and power models. We're going to be modeling with quadratic and power functions. If the graph of a set of data has a pattern that approximates the shape of a parabola or part of a parabola, a quadratic function may be appropriate to model the data. If the graph of the data does not indicate a turning point, then a power function may be appropriate to model the data. Example 1 is on artificial intelligence. Enterprise AI refers to the use of artificial intelligence in enterprises to transform business operations and strategy. The table gives the revenue in billions of dollars from artificial intelligence for enterprise applications in North America for the years 2016 through 2025. We want to create a scatter plot of the data with x equal to the number of years after 2015. So we're going to go into our stat editor and enter the data. X is the number of years after 2015. Now we'll put our y into the L2. It's already been scaled in the table for us. Just double check to make sure that you don't have any typos in entering all the data. It's easy to do to make a mistake. Alright, looks good. So we'll first want to turn our stat plot on. So let's go to our stat plot and turn it on, and you see the scatter plot is selected. We're taking our x's from list 1 and our y's from L2, and we'll get this little bubble for each data point. It's a little easier to see. Now that our stats are on, we'll do a zoom stat, and that makes a nice box around our data. Okay. And now we're going to find the quadratic function that is the best fit for the data, with x equal to the number of years after 2015 and y equal to the revenue in billions of dollars. So what we'll do is go into our stat menu again. So we're going to go stat and calculate. We've done linear regressions before, and now we're going to do a quadratic regression on this one. Okay, remember your screen may look different. Just figure out which model you have and what you need to modify. We're going to go ahead and store this regression equation. It's a good idea to do that. Go vars, yvars, save it as a function. Let's put it in y1 and go ahead to calculate. So they're giving you this form of the equation and the coefficients. We can go ahead and write that in here. So y equals 0.228 x squared plus be a negative, so let's go ahead and say minus 0.941 x plus 1.255. Again, we're recording just 3 decimal places here. You have the model in full available to you on your calculator. So when you're using this to calculate other numbers, you want to use the model that's in your calculator, not the rounded model that you've recorded. We're going to graph the aligned data and the model on the same axes. So we've already graphed the scatter plot. the reason we went ahead and saved this, stored this in Y1 is because we see this coming up. So go ahead and graph. And since we did save the function in there, it's ready for us to view. So there we go. So graph the aligned data and model on the same axes. Is the model a good fit? Yes. We want to use the model to find the enterprise artificial intelligence revenue in 2026. Since X is the number of years after 2015, X is going to be 11 here. So we can find that, hit trace. You'll notice it's actually tracing the plot points, your stat plot, so you don't want to do that. Arrow up or down so that you actually get onto the function that we found by doing that quadratic regression. And so you can trace along, but you can type in 11 and it doesn't like that. We probably don't have a big enough window. So let's go in. Yeah, the X max is 10.9. So we need to change that a little bit. Let's go ahead and put a 12 in there so we can definitely trace through 11. We'll do a zoom fit. Okay, so it extends out a little further. So we can do a trace. Again, you need to get onto the graph, not onto the plot points. And oops. Punch in 11, and there we go. It's about 18.604. So 18.604, and that's billion dollars. So make sure and put the billion and the dollars on that so you've got that, all that information that you need. Example 2 is on the cloud. North American cloud computing revenues from 2008 and projected to 2020 are shown in the table. We want to create a scatter plot for the data with y equal to the billions of euros of revenue and x equal to the number of years after the year 2000, and determine the function types that can best be used to model the data. So let's go into our stat, and we can just overwrite the data or scroll up onto the list name and clear it. You don't want to delete those lists, just clear them. And then we'll enter our data. X is the number of years after 2000. Okay. And scroll over to the L2 and start entering your data there. Okay, double check all of your entries. Make sure that you have all your data entered correctly. No typos. And now we're ready to go ahead and get a scatter plot. So our stat plot is already on from the last time. We just need to do a zoom stat. Zoom stat so that we can get that graphed. we have our old function in there. Take that off if you want. There you go. And that looks like, it could be the right half of a concave up parabola. It could also be a power model, something maybe quadratic. So either one of those, try it and see what's going to fit best. So first we want to see if we can find the best fitting quadratic model for the data. So we'll go back into our stat menu and calculate that quadratic regression. List 1 and list 2 is where we're pulling from. And let's go ahead and store the regression equation. So vars, y vars, and store it into y1, and then calculate. So we'll have y equals 0.231. There we go. We want to graph that aligned data and the function on the same axes. There we go. And it looks like a reasonable fit. So we want to use the model to predict the revenue in 2019. So we can do a trace. Again, make sure that you're on the function. And the x is the number of years after 2000. So 2019 will be an x of 19. And we get 51.966. So 51.966, and that's in billions of euros. So is that close to the estimate that is in the data projection here? The data projection says 51.785 in the table, and yeah, that's fairly close. In what year does the model predict the revenue will be 65.98 billion euros? So this is what your y is. X is the number of years after 2000. This is y. So what we can do is put 65.98 into the graph as y2 and do an intersection of graphs method. Now, looking at the window, this is in the table. Y max is 68.23, so we should be able to see 65.98 in the graph, and you can see the intersection. So we can calculate the intersection between y1 and the y2. So we'll go ahead and hit enter and have it guess for us. It will hop onto that intersection and gives it as 20.998, so about 21. So that'll be 21 years after the year 2000. Should be 2021. Example 3 is on female physicians. The table shows the number of female physicians in thousands in the United States for selected years from 2015 and projected to 2040. Let X represent the number of years after 2000 and Y represent the number of female physicians in thousands. So we first are going to find the power function that models the data. So that we can see the data, let's go ahead and do a scatter plot. So go into the stat editor, clear out your data from the last example. And the years after 2010, it's going to be 5, 8, 11, 15, 20, 25, and 30. They've already scaled the data for the y, so we can put that into L2 as is. Okay, go back up and double check to make sure that you don't have any data entry error. Okay, and then we'll go ahead and run our regression. So we'll go ahead and go into stat plot. It's gathering the data from L1 and L2. So we can do a zoom stat. And there it is, looking good. And let's do a power regression. So go into your stat menu and over to calculate, and we're going to do down here, go down, do a power regression right there, and pull from list 1, list 2. We'll go ahead and store the regression equations. We know we'll want that. Okay, so that is a y equals 192.467 x to the 0.22021. And of course, graph the data in the model on the same axes, so it's a good thing we went ahead and stored that function. Go ahead and graph, and it looks really like a pretty good model. And we want to know, what does the model predict the number of female physicians to be in 2045? So that would be an X value of 35. Let's go to our window. We don't have quite that big a number. We can go ahead and fix it if you want. And 36. And we'll do a zoom fit. And we can trace. Again, don't trace your plots. Scroll up or down so that you can get onto the function that you found that that line for, and we'll put in 35. Hops onto that place on the graph and gives an x of 35 and a y of 421.091, and that's in thousands. So 421.091 thousand female physicians in 2045. Another way to find that number is if you go to the table, you can scroll down to an X value of 35. You can even set your table to start at 35. There's other ways to do this, but we can look at those later. 421.091. There's your number, your output. All right, for comparing linear and quadratic models, just recall that when the inputs are equally spaced and the first differences of the outputs are constant, or in nearly constant, approximately constant, then a linear model is going to give a good fit for the data. Similarly, if we compare the differences of the first differences, that's called the second differences, and we get something that's constant or approximately equal, then that can be modeled by a quadratic function. Comparison of power and quadratic models. You know, you can put those both into your calculator and just compare both of them, see which one is a better fit. You can also, remember, you can also turn your stat diagnostics on and compare your correlation coefficient and your coefficient of determination on some of those. Okay, so we can try that in our next example. This one is on purchasing power. So the prices for goods and services traditionally rise over time, so the value or purchasing power of a dollar will decrease. The table gives the purchasing power of a 2012 dollar for selected years from 2012 and projected to 2050. The table indicates that a 2018 dollar purchased 87.7% of the goods and services that could be purchased for a dollar in 2012. So we want to create a scatter plot of the data with x equal to the number of years after 2010. So let's go into our stat editor and clear out that data and start entering the data. And make sure you don't have any typos before you go on. There we go. And put the Y into list 2. Okay, so just double check your numbers before you continue with the problem. We don't want any typos to cause issues on us. All right, we have our data put in, and you make sure that your stat plots are on, that you're drawing from list 1 and list 2, and then you can do a zoom stat to get a nice window around your data points. So find the quadratic function that is the best fit for the data with x equal to the number of years after 2010 and y equal to the purchasing power of a 2012 dollar. So again, we'll go into stat and calculate. I'm going to select quadratic regression. Taking our data from list 1 and list 2. Of course, let's go ahead and store our regression equation in y1 and calculate that. And go ahead and record that. Y equals there you go. And we want to graph that aligned data and the quadratic model on the same axes and determine if it's a good fit. So there we go. Yeah, it's a good fit. The shape of the scatter plot of the data looks as though it could be also modeled by a power function. So let's find the power function that's the best fit for the data, with x equal to the number of years after 2010 and y equal to the purchasing power of a 2012 dollar. Then we'll report the model with 3 significant digits. So let's go into stat and calculate and scroll down again to power regression. Okay, we're taking our data from list 1, list 2, and let's store the regression equation this time in y2 so that we're not overriding our quadratic regression. And calculate that. We'll have y equals 1.59 x to the negative 0.343. And graph the aligned data and the power model on the same axes. Let's go back to that. We'll turn that first regression off so we're only seeing the power model. I'm going to graph. And it's not looking so great. It's not a good fit. So use the better model, which we've determined is the quadratic regression. Turn that back on and turn the other one off. We're going to use the better model to find the year in which the value of a $2012 will fall to 60 cents. And we'll go ahead and put our 60 cents down here. Remember, it's going to be a 0.6. This is given in dollars, so 60 cents is going to be $0.6. And we'll graph. Go ahead and find an intersection. So calculate the intersection between y1, go ahead and hit enter, and y3, hit enter, and enter one more time. That's going to give us a value of 60 cents there at 21.9, so about 21.9 years after 2010. So that'd be the year 2032. It will be 21 years after 2010 and then 0.9 into the next year, so the year 2032. Let me know if you have any questions.